I'd never heard about milking algae before. Our next speaker is Dr. Robert Duncan, Vice Chancellor for Research at the University of Missouri, Columbia. I know that many of the folks in this room saw the 60 Minutes show of last Sunday. It was very nice of them to show that cold fusion segment just before our energy summit. But it certainly is a fascinating story. And Dr. Duncan was featured in that 60 Minutes segment, having been recommended by the American Physical Society to serve as an independent scientist to look at the multiple claims of successful cold fusion experiments. Yesterday, Dan Cole from Ameren talked about the fact that there's no silver bullet to solving our energy challenges in the world. But I must say, he talked about the need for silver buckshots, and that's probably what we're going to need to do. But I must say, if this claim to successful cold fusion turns out to be real, and of course that's a big if, conceivably the world could have a virtually limitless supply of energy in the future. Let's hope. As an expert in low-temperature physics, Dr. Duncan has also worked for NASA, the Institute for Advanced Studies at Los Alamos National Laboratory, and the New Mexico Consortium, an organization that uses the strengths of New Mexico's research universities to build scientific connections around the world. He received his bachelor's degrees in physics from MIT, his doctorate in physics from the University of California at Santa Barbara. Please join me in welcoming Dr. Rob Duncan.
Thank you very much for that introduction. Hello. Well, thank you very much, and I'd like to thank the organizers for the opportunity to speak here today. Thank you all for coming. This has been a wonderful summit. I was really impressed by the focus and theme. We recently got our second Prius, so I don't know whether we have Priuses or Prii. But as a prominent representative told me here in Missouri, I don't emit smog, but I do emit smug. So I'll try to minimize my smug emissions with my Prius. But then to hear, T. Boone Pickens talk about the right way to go on energy policy, and with $2 billion, that's very enabling. So no one's going to stop him. So that's kind of interesting. And I'd say the most inspirational thing has been listening to the governor say that in these difficult times, it's time for innovation, it's time for discovery, it's time to lean into the challenges, not back away from them. I couldn't agree with that more. And so this has been a very, very exciting summit. What I'd like to do now is give you a talk that's more about the importance of objective scientific method when you approach new things you don't understand. It'll be more important to kind of take that away from this and how the media may play into or possibly hinder the ability to approach things that way, not to their fault, but to just the nature of mass media, than to really focus on the science. But let me say I would love in a different venue to go into extreme depth on the science. So hopefully we can schedule within the next month or so an opportunity to discuss the science in much more detail. All you really need to know before we get started is this cold fusion question, and we'll review it in just a second. You have an apparatus that has a tiny, tiny palladium foil, okay? This is only about 0.3 grams. So this foil is about 1/100th of an ounce. This foil is tiny, okay? And nonetheless, there have been reports by now, 20 independent laboratories all over the world that have reported exceptional heat releases on the order of what we call a million joules, which is pretty amazing. To put that in perspective, these spotlights are emitting about 300 joules per second each. So joules, a tiny amount of energy, but to get a million joules from a tiny piece of palladium foil, as has been reported, is really phenomenal. So try to set that scale. But all you really need to know here is that excess heat means you put in some amount of electrical energy into this foil to load it with a heavy hydrogen isotope called deuterium. And then you compare the amount of heat that comes off sometime later to the amount of electrical energy you put in. Okay? So I'm not going to go really into a lot of technical drawings or something like that. I'd love to do so in a different venue. But rather just know the excess heat is the amount of additional heat that comes off compared to the amount of electrical energy you put into the process. That's what we mean by excess heat. Well, with that, I'd like to go on and talk about the 60 Minutes piece. I actually had recommended the term cold confusion for reasons you'll see here in just a second. And it's interesting, most people don't realize that the first report of a possible nuclear fusion reaction in palladium loaded with deuterium or heavy hydrogen occurred in Berlin, Germany in 1926 by two professors. And actually, when you go back and look at what they were doing experimentally, they were in fact seeing essentially the same physical system that we've been discussing at length today and since Pons and Fleischmann's press release in 1989. It's interesting that there's another type of cold fusion that is really, really well known and confirmed scientifically. In fact, this paper by J.D. Jackson that you see here from Princeton University at the time, Catalyst of Nuclear Reactions Between Hydrogen Isotopes by Mu Mesons. Notice it was published on Tax Day in 1957, if that was still Tax Day in 1957. But this is one of the best papers I've ever read. Very, very good. And I really, for those in science, I'd say this would be a very good thing to read. Now, this was fusion at near absolute zero temperature between hydrogen deuterium atoms that were in their liquid state near absolute zero. And again, this has been confirmed. The problem is mu mesons are rare, and after about 10 to 100 reactions, they stick to the alpha particle, or the helium that's produced in the nuclear reaction, and hence are taken away from the reaction. So that's what limits the ability for this to become a viable energy source. My first guess is there might be something here that applies to what we're being discussed now in terms of cold fusion, but I certainly don't know that for sure. I don't believe everything I think, and I ask you all to not believe everything I think. You know, the reason I'm an experimentalist is I can't believe everything I think. I have to conduct controlled experiments to figure out what's really going on. Okay? Well, now, when we go on, cold fusion continues, and this is an extremely important point, but now in the age of mass media, okay? Now in our modern media age. Well, in 1989, Pons and Fleischmann from the University of Utah held a press conference to announce that they had discovered this wonderful new form of energy that would alleviate all the world's energy problems, okay? That was, to say the least, a little bit of a jump, okay? They had seen some fascinating new science, science that now I realize after 20 years is real, okay? But the thing is that in seeing it, there was such excitement. You know, the idea of the University of Utah is, wahoo, okay, our ships come in. Press conference, announced to the world we'll solve the energy problem. Very, very bad media.